Hey there, ladies and gentlemen. Today we're going to be solving systems of equations with substitution again. So today is actually the second day you're going to be seeing this. So we're going to look at it just a little bit differently. So as we did yesterday, we had it already set up where we could directly take something and substitute it in. So in this case, I'm going to take the 3x minus 4 and substitute that for y because it says y is equal to that expression. So when I do this, I have negative 2x plus 5 times 3x minus 4, and then the equals 19 is still there on the other side. So now I have only x's in my equation. I'm going to go ahead and solve for x. So I'm going to start by distributing okay, and that equals 19. So now I'm going to combine my like terms. So this would be 13, I believe. Yes, 13x minus 20 equals 19. Now I'm going to add the 20 on both sides. So 13x equals 39. Dividing by 13 on both sides, x has a value of 3. So that's kind of nice. It gave us a nice pretty whole number. So now I'm going to go back to one of my equations. I'm going to go ahead and use that second one. So I'm going to substitute 3 for x to find out what the value of y is. So this would be 9 minus 4. So 5 equals y. So then my coordinate of intersection, if I were to graph these, would be 3, 5. So this would be our solution. This is the x and this is the y. Obviously, we can go back and substitute, but I'm going to save you guys some time while watching this video. So if you ever get a solution and you're like, I don't know, that doesn't seem right. So you can always go back and substitute. All right, now this one is a little bit trickier because we have to look at, well, this question is asking how many solutions we have. So then in this case, what we're going to do is get y by itself. So I have 6y plus 5x equals 8. So I'm going to start by subtracting that 5x on both sides. So I have 6y equals negative 5x plus 8. I'm going to divide by 6 on everything. So y equals negative 5, 6x plus, let's see, they're both divisible by 2. So let's see, it would be 4/3. So this one's kind of yucky with those fractions. So we're looking at our slope to tell us, I don't know why I put that there. We're looking at our slope to tell us if it is 1, infinite, or no solutions. So now I'm going to take that second equation and get y by itself. So I'm going to start by subtracting the 2.5x. So I have 3y equals negative 2.5x plus 4. Now I'm going to divide everything by 3. So I have y equals negative 2.5 over 3x plus 4/3. Now, if you notice, the y-intercept is the same. So then I'm going to think, you know what? I wonder if my slope. So if I look at 5 over 6 and I divide it by 2, dividing 5 over 6 by 2 will get me 2.5 over 3. So that means in this case we have the exact same equation, the exact same y-intercept. So this would be infinitely many solutions. All right, here's another one. We're going to do our solving this system with substitution. So y equals x minus 1. So I have x minus 1 equals 2x plus 7. So I substitute that there. You could do it either way. It doesn't matter. So now I'm going to get my x's and my y's together. I'm going to start by subtracting x. So I have negative 1 equals x plus 7. I subtract the 7. So now I have negative 8 equals x. Easy enough. So now I'm going to go back and substitute that negative 8 where there's an x. So y equals negative 8 minus 1. So y equals negative 9. So my coordinate would be negative 8, negative 9. All right, last but not least, we're going to write a system here. So it says you pay $22 to rent 6 video games. The store charges $4 for new games and $2 for old games. So what we need to start doing is designating X and Y. I don't know why I did that backwards. Let me fix that. That bothers me. So we're going to do X and Y. So I'm going to go ahead and say X is new games, just because it's listed first. And so I did that wrong. Why isn't it letting me erase? Let's try this instead. Okay, here we go. Let me try that again. So this is old games. New games are $4. Old games are $2. So we're talking about two things: the total number of games and the cost. So we would have X plus Y equals 6 because he bought a total of 6 games. And then we're going to talk about the cost. So this would be 4X plus 2Y equals 22. So now we need to get one of the variables by itself. Let's see here. I wonder if this will show up well. So I'm going to take that X plus Y. That's not going to work. And I'm going to get Y by itself. So I'm going to subtract X on both sides. So I have Y equals, I'm going to leave it 6 minus X just for the ease of it. It doesn't matter. So I have 6 minus X, which is equal to Y. So I'm going to use this second equation and substitute 6 minus X for Y. So 4X plus 2 times 6 minus X equals 22. So 4X equals 12 minus, not equals, so plus 12 minus 2X equals 22. So 4X minus 2X is 2X plus 12 equals 22. I'm running out of room. So 2X equals 10, divide by 2. So X equals 5. So that means he bought 5 new games. So if I go back to my X plus Y, if X is 5, that means Y has to be 1. So then my solutions would be 1 old game, 5 new games.